Hello, this is Ms. DB, and in this lesson we're going to look at graphing functions, especially the examples from your worksheet. Come on, there we go. So if you are going to graph a function with a bunch of coordinate points, the x-coordinates are the first and the y-coordinates are the second part. So you would set up your grid system, your x and y coordinate system, and 0, 4 you put a point, 1, 5 you put a point, and so on. Do not connect the points if you are just given a set of coordinate points like this. If it's a set of unconnected points like this, that's discrete. If it's connected, it's continuous. This is an example of a continuous function. Make a table, graph the points, connect them, because unless they tell you what the domain is, or they list a set of coordinate points, and they tell you that the domain is only integers, we will assume that the domain is all real numbers. The algebraic expression used to define a function is called the function rule. So we've got equation, function, function rule, lots of different ways to say the same thing. 5x plus 3 here is the function rule. I didn't go over how to graph a line, but you should remember that from algebra. Here's an example of a real-world kind of situation. Before you would graph this, you would have to write a function. It says a carnival charges a $5 entrance fee and $2 per ride. So you need to figure out your independent and dependent variables. R can be the number of rides, and the cost, which is dependent, depends on how many rides. So cost is going to equal the entrance fee plus the number of rides taken. Your dependent variable, again, is the cost, and your independent variable is how many rides you're going to take, the number of rides you take. All right, so we can write this as an equation or a function where the cost of the number of rides, the C of R, is equal to 5 plus 2 times R. Where's the 2 come from? Because it says that it's $2 per ride. So now you have a function, and you could graph this because this is a linear function, and in this case, your y-intercept would be 5, and your slope would be 2. This is another example where this is the same example, but it says what is the value of the function for an input of 12 and what does it represent? So you would write your function again, which was on the last page, C of R equals 5 plus 2R, and we just replaced our R with 12 because that's how many rides it's going to be. And you find that your cost is $29. So when it says what does it represent, it means that it's going to cost $29. So you should be able to say, what does this mean when you're done and for real-world problems? Okay, so now what I'm going to do is open up the Sketchpad file that goes along with this assignment, because in the online world, we need to be able to have a way of graphing when you don't have a way of me seeing your graph paper or your, sorry, I'm trying to get this to be exactly the right size so you can see the controls over here. So what we have is this wonderful program called Sketchpad where you can graph things, and then I can see, you can save this and submit it. Remember that this is found in the virtual student desktop, so you have to log into the Minnesota Online High School virtual desktop with Citrix, open this, and when you're done with this, save it and stay in the virtual student desktop in order to go to Blackboard, open up your assignment, and find your assignment. This will be saved in the virtual desktop. All right, so our directions are to graph each function by plotting points. You see there's some tabs down here, and I clicked on directions. When you're given a function, you choose the x values or use the given domain values, then plug them into the function to find the y values. To make a point in Sketchpad, go to Graph, and then go to Plot Points. Do not connect the points if it's discrete. if you're given specific values for the domain. Do connect the points if it's continuous, if you have all real numbers as the domain. Use a segment if your domain has a minimum and maximum value, or use a line tool with the arrows at both ends. Hold this down with your mouse key and choose this one if the domain is all real numbers. All right, we're ready to get started. Here's problems 1 and 2. Now, is it the top of the page? Oh, no, not quite. There we go. I had to move it up. It says graph the function for the given domain y equals 3x minus 1, and then they give you specific values of the domain. So this is just going to be a set of points. So sometimes you might have to solve that for y first, but that's already been done. And now we're going to take those values of the domain, -3, -1, 0, and 4, and we're going to replace them wherever you see an x and find what the y value is. The first one's been done. Put in -3, and we get 3 times -3 is -9 minus 1 is -10. So our first point to graph, plot points, is going to be -3 and -10. And then click on plot. Now I'm going to scroll down a little bit to show you where that point ended up. There it is. It's a little bit lower than what my view showed before. And now I'll do the next one. Okay, now I need the x value of -1, the domain value of -1. So 3 times -1 would be -3 minus 1 would be -4. So my next point, I'm just using the text tool here, would be -1 for x, because that's what I used, and -4 is what I found for y. So now the next point that I need to graph is -1 and -4. And there's that point. And I'll complete this for and you can find all of the coordinates first and then plot all of them in a row if you find that easier. Let's see, this would be -1 because 3 times 0 is 0 minus 1. So my coordinate would be 0 for the x coordinate and -1. And then I'll do the last one as well. So at 4, I'd have y equals 4 times 0 minus 1, which is 4 times 0. Oh, I put that, sorry, I did that wrong. It's 3x, not x times. I was looking at that wrong. So I'd have 3 times 4 minus 1. And then do the math. 3 times 4 is 12. 12 minus 1 is 11. Unfortunately, in Sketchpad, there's not a good table. Well, there is table tools, but not exactly the way we want it to work. So 4, 11. So now I need to graph those last 2 points because I had not graphed 0, -1 yet either. 0, -1. I'm just using the numbers on my keyboard to enter these. And then plot, and then 4, 11. Now, I am not going to connect these points. However, they should be in a line because this is a linear function. And they are in a line, but I'm not going to connect them because the domain value is only specific domain value, so I would just want a set of points. And then number 2, you can graph on the same. They will both be on the same one, that's fine, but you'll do the exact same thing. For this one, the function is x plus 4, and then for the domain values, you have -5, -3, 0, 4. So they're already picked for you. So those are the x values. You plug them in, you find the y value, and then you graph those 4 points. Now, if you want to, this is the selection tool, you could select the points that go together for one of the problems, and you could turn them a different color by going to display. I'll make them all be medium, and I'll make them all be, I don't know, green. So maybe for number 1, all my points are green, and then maybe for number 2, I'll let, they can all be red, whatever you want to do. I'm not going to connect these points in this problem. Let's look at 3 and 4. I have to go up to find 3. It says graph the function for the given domain. Y equals x at the domain of x is between 0 and infinity. Well, that's another way of saying that x has to be greater than 0. So I don't want any negative x values. So the table is not here. You can make a table, or if you find it, I'm going to use my pen tool here. That was really crooked. I'm going to just make a table with my marker tool. It's still crooked. I have to pick x values that are greater than 0. So let's say 1, 2, and 3. Well, x equals y, y equals x, these are going to be the same thing. So I can put some points on here. But I would connect these points with the line tool. Let's plot some points. 0, 0. Oh no, not 0, 0. 1, 1 is my first point. Second point is 2, 2, and then 3, 3. However, I'm going to use a ray tool that has an arrow at one end, and I'm going to start here and then go this way. That shows that it's supposed to be greater than 0. I could put a little circle there to show that, but this is close enough. And then my line will go up and onward forever in the infinite direction. For the next one, we want our domain to be between -2 and 3. So my segment will be, it'll just be a segment. It won't be a ray. It'll be one with no arrows. And so when I pick my coordinates to use for the x, I want to pick values between -2 and 3. Let's say I'll do -2, 0, and 2. And when I plug these points in, then I'll get my y values, but I need to make maybe I should go all the way up to 3 so my point will show up on the graph. So at 3 I would have, what is that, -4x plus 5. So I'd have -4 times 3 plus 5. -12 plus 5 is -7. At 0, I'm going backwards here, I'd have -4 times 0 plus 5. That's 5. And at -2, I would have -4 times -2, that's a positive 8. 8 plus 5 is 13. I'm just going to plot 2 of those points right now. I'm going to point the 2 endpoints. -2, 13. And then I'm going to do the 3, -7. So -2, 13 is right there. And then 3 is right here. So what I want to do is I want to connect those 2 points with a segment tool, except that I can't see the end of it. I'm going to pick that back up and move it to, oh shoot, I didn't get it picked up. Oh, I see. I have to click this arrow tool first before I can move it. There we go. Now, does my other point lie on that line, 0, 5? Is that what it was? Yes, see, it's a little bit off, but it's very close. 0, 5 is right about there. So it would make a straight line. And it's got the correct domain on there. And then here's the next couple of problems. 5. This one, the domain is going to be all real numbers. So on these problems, you can just go ahead and use the line tool to connect your points when you're done, because all real numbers would just be a line. And then here's some, you can pick these points. You don't have to pick these, but there's a table set up for you. and they found the first point is going to be negative 8. And here's y equals 1/2 x plus 4, and you would graph this one. So we're going to connect the points when we're done with both of these. You'll have two linear equations. They'll both be straight lines. These are both linear. In number 7, you have to solve for y first, so you'd subtract x from both sides. Y equals negative x. 8's already solved. These two will be quadratic. These are going to look like parabolas. They have an x squared in them. So you can't use straight line segments to do that, but you can use a marker tool. This is going to turn out badly, but to attempt to make your parabola will look something like this. That wasn't so bad. Or maybe it'll look something like this, depending on whether it opens upward or downward. And here is a little hint, if you're watching this, that you can check your graph when you're done by going to Graph, Plot New Function, and type in the part after the equal sign, as long as it's f of x equals or y equals. So I can type in 2 times x squared, this is the square button, and then minus 7. Make sure that this function looks just like this, and hit OK, and it will graph it for you. And then you can check if your points are on this graph, and if they are, then you made it correctly. It's easier than trying to connect these points with the marker tool. All right, good luck. Let me know if you have any questions. Thank you very much and have a great day.